So what on earth does a self-driving car have to do with your next doctor's visit? Sounds kind of like the start of a bad joke, right? But the answer connects two of the most complicated things we do: navigating a busy street and diagnosing a disease. Let's get into it.
I mean, seriously, it seems like a totally absurd question. One is all about traffic and tech and steel. The other is about human health, biology. But the thread that ties them together isn't just some neat little fun fact. It's already changing our world.
And the answer, of course, is artificial intelligence. You see, the same fundamental logic that teaches a car to spot a pedestrian in the pouring rain is now being used to find tiny anomalies on an MRI scan. And listen, this isn't science fiction. This is a parallel evolution that's happening right now.
To really wrap your head around this, we have to start with the most basic thing of all: just seeing. How does an AI actually learn to perceive the world?
For a self-driving car, the world is just this chaotic, messy flood of information. Pedestrians, stoplights, other cars, road signs. Its number one job, before it can even think about moving, is to see and correctly identify every single one of those objects.
And right here, this is where it all clicks. A car's AI uses what's called 3D object detection to spot a person crossing the street. A healthcare AI uses medical image analysis to spot a tumor. When you strip it all down, the basic task is exactly the same: find one critical signal in an absolute ocean of noise.
But, just seeing individual things isn't really enough. The real magic, the part that's truly powerful, is when the AI starts connecting information from a bunch of different sources. Think about it. A car can't just rely on its cameras. What happens if it's super foggy, or the sun is glaring right into the lens? To build a complete, trustworthy picture of what's going on, it has to blend or fuse information from all of its sensors at the same time.
And this is where that parallel gets even deeper. A car fuses data from its LiDAR, its cameras, its radar, all to build that 360-degree view, while a health AI does the exact same thing. It fuses lab results, genomic data, imaging scans, and clinical notes. In both fields, the goal is identical: create one single, holistic picture that is way, way smarter than any of its individual parts.
Okay, so the AI can see, and it can put information together. But what's its real job here? It's not about replacing the human. Not at all. It's about becoming the ultimate co-pilot.
This quote, man, it just absolutely nails it. The whole point is to give us humans, whether we're behind the wheel of a car or at a patient's bedside, an extra set of eyes and ears. One that never, ever gets tired and never blinks.
And why is that co-pilot so incredibly important? Well, because we're human. We have limits. A driver just can't physically watch every single car and every single pedestrian around them all at once. And a doctor, they face a similar and honestly probably even bigger challenge.
I mean, just try to picture a hectic intensive care unit. You've got one clinician monitoring dozens of constantly changing data streams for multiple critically ill patients. Or think of a radiologist who has to read hundreds of incredibly complex scans every single day, searching for one tiny, almost invisible spot. This is where information overload becomes a genuine risk and where it's just possible for crucial details to get missed.
And this is where the AI co-pilot becomes a game changer. In a car, it's paying attention to everything at the same time, in parallel, acting like a safety net. In a hospital, it's doing the exact same thing, continuously monitoring all the patient data 24/7 to catch those subtle, early warning signs of a crisis, like sepsis, often hours before a human might notice.
So this partnership between humans and AI, it does more than just make things safer in the moment. It actually has the power to completely reshape our day-to-day lives and even our entire systems. Just think for a second about what happens when you can finally offload a huge, mentally draining task. It doesn't just make that one thing easier, it totally changes how you use your time and your brain power.
For a driver, a fully autonomous car could turn a stressful hour-long commute into productive time you can use to work or read or just relax. And for a clinician, an AI that handles the boring, repetitive stuff, like paperwork and initial screenings, frees them up to do what only a human can do: actually connect with a patient, show empathy, and make those really complex, nuanced decisions.
And this ripple effect, it doesn't just stop with one person's day. When you fundamentally change the core jobs of millions of drivers and millions of doctors, you inevitably start to redesign the very systems they work in.
Just like self-driving cars will completely change city planning, health AI is set to completely redesign how we deliver healthcare.
We're talking about things like remote monitoring that keeps people out of crowded hospitals, AI-powered triage in the ER to get the sickest people help faster, and even predictive models to manage the health of whole populations. Each one of these is a massive shift in how we think about health.
But, and you knew there was a but coming, this incredible future isn't here yet. It's not a guarantee. There are some huge challenges on the road ahead for both cars and for healthcare.
Let's be real. We've all seen the headlines about self-driving car accidents. The tech is not perfect. And guess what? Neither is health AI. We can't just flip a switch and expect it to work perfectly in every hospital for every single patient.
And the hurdles we have to clear are really, really big. We have to figure out how to solve for bias in the algorithms, to make sure a tool trained at one hospital actually works for patients everywhere else. We have to make sure the AI isn't some black box, so that doctors can understand why it's making a recommendation. These things, safety, fairness, trust, they're everything.
But here's the good news. We don't have to figure this out from scratch. The automotive world has basically given us a blueprint. You don't go from a lab test straight to deploying cars all over a city. No way. You start with super controlled trials. Then you move to slow, incremental rollouts in specific places. And only then, after tons of testing, do you integrate it into the bigger system. Healthcare has to follow that same cautious, safety-first path.
So when you put it all together side by side, the parallel is it's undeniable. A car's object detection is the same challenge as medical image recognition. Sensor fusion is multimodal patient data. Overcoming a driver's limits is the same problem as solving for a clinician's cognitive overload. And in the end, transforming our transportation system gives us the exact blueprint we need for redesigning healthcare.
The takeaway here is pretty clear. The same kind of technology that is changing our roads is already making its way into our hospitals. So the real question isn't if this change is coming, it is. The question is whether we'll be smart enough to apply all the tough, hard-won lessons from the automotive world to build a safer, a more effective, and maybe even a more human future for medicine.